Hi guys, welcome back to another session on vectors. Today we are moving away from that introductory vectors and we're getting into our first rule. So one of the first rules of vectors is perhaps the most easily mistaken. So I decided to do a short proof so you guys can get a visual understanding as to how they came up with the rule. So on screen, I have a typical Cartesian plane. We have our lovely x-axis and our lovely y-axis. We also have two straight lines on there, and I am going to call my vector OA. I'm going to give it a magnitude. Let's just say that is a magnitude of x. And I'm also going to call my vector OB going in that direction. I'm going to give it a magnitude. Let's just say y. So we have two vectors on screen, OA and OB. They are position vectors because they both begin from the origin and have their magnitudes. Now, let's just say I wanted to connect the lines, the points, sorry, A to B. And in connecting them, you can see that they form another vector. And if I were to draw some arrows on there to represent direction, let's just say in this direction, then we have another vector starting from A and stopping at B, and we don't know its magnitude. Do you know you can actually use something called a vector rule to determine the magnitude of vectors that are part of a triangle like that? Let me show you how. Now there's a rule, but we are going to prove that rule today. So when you're doing vectors, you always want to think of them, besides being straight lines, I like to think of them as routes. Routes on a journey. Like you're walking along a road, you start from your home, you know, everybody lives in a house, and say our house is our original destination, so we call that O. And then say we stop in a mall, we'll call that M. And then we end up heading off to school, we'll call that S. You know, so we kind of made a couple of stops along the way and we took different routes to get from point O to M to S. So if I had to use my knowledge of vectors to represent this route, I could safely tell someone, hey, I started from my home, point O, and I stopped at the mall in that direction. And if I knew the distance between those 2 points, let's just say from home to the mall is what, 5 miles, then the vector OM would be equal to 5. And then if I told them about my journey continuing from the mall, then we'd have M towards S in that direction. And let's just say that distance was 3 miles away. So we moved a distance of 3 miles. So we took two routes from home to the mall and then from the mall to school. Now, at the end of the day, if I told somebody collectively that I started from my home and then I ended up in school, and in total, the distance from my home to school is 8 miles away, then you can tell that person that if you wanted to use vector notation, from O towards S gives us a magnitude of 8. Now let's just say things get way more complicated. And there were several routes in between. There's rules that you can use to calculate your journey and decipher very easily how you get from one point to the other. Let's look at our thought process in this diagram. So I'm going to erase this here on screen. It was just a little side trick I like to teach kids about thinking about a vector as a route where direction is extremely important. So let's just say we wanted to start, right? We had a journey to make and we wanted to make sure that we started at point A. And we want to end at point B. Now in this diagram, we can go ahead and start at point A and move towards point B along this route. Now what if this route had, say, a car accident and there was no way you could take that route? You couldn't pass, you couldn't get through. So you had to take a detour, alternative route. Then how is it possible for us to get from point A, where we are, and end up at point B still? Well, there are actually alternative routes because this diagram seems to have connections. For example, if I were to start at point A, and then I were to move towards point O, that's one vector in that direction from A towards O. Now, because we need to stop, we need to end, we want to reach the point B, we cannot stop here. So we must continue our journey and we'll represent that by adding. We are going to join a second route. So now we are officially at point O. We started at A, we're not now at O, and we want to get to B. So we can see on this diagram there is a route directly from O heading towards B. So we are going to take that route. And finally, taking that route, you can see that we started at point A, we traveled along towards point O, and then from O, we traveled towards point B. So we have safely reached from A to B. So this is actually equal to the vector A to B. It's just we took a different route. Now, what about the values? We had originally values for the vector O to A. We had O to A having a magnitude of x, but O to A was in a particular direction, heading towards A. So if we wanted to know from A to O is actually in the opposite direction. So because the length x remains the same, we just place a negative sign to denote the fact that our direction alone has changed, but our length of our route, the length of our line, does not change. Then we continue our journey. Now, our journey entails starting from O and then ending towards B. Now, similarly, we had recalled that from the beginning, O to B was given by a magnitude of y. And O to B actually is in the direction of y. So there's no sign change. So we retain that positive value. So what we can say about this journey is that we now have a magnitude for AB of negative x plus y. So finally, if you wanted to represent your answer in a more simplistic form, we can say that we worked out AB to be equal to y subtract x. Now, this is where a very important rule comes to life. Now, there's a rule that says if you're moving from a vector A and you want to get to a vector B, the rule says this breaks up into two vectors, OB subtract OA. Now, I'm going to show you guys how we are going to use our solution to generate that rule. Now, let's try to remember what y was equal to. Now, if you recall from above, our vector y, our magnitude y, sorry, is denoted by the vector OB. So we are going to replace that magnitude with the vector that it is associated with, which is OB. Subtract. What about x? What is x equal to? Well, if you go back in the beginning, you can see that your vector OA is equal to x. So we are going to replace the magnitude x with its vector OA. Now, do you see it? There's your rule. And that's how you get it, folks. I know. It's amazing. I really like this rule because I know a lot of times students tend to break this up into OA minus OB. It's a common mistake. But if you really were, say, lost in exams and you couldn't remember the order of your rules, what you can do is you can try to go to some clear space. You can draw two straight lines like these, and you can try to develop the rule, and you will be able to clearly identify that it's always the second letter subtract the first. So for example, by extension, of course, there's a by extension for this rule. If the vector AB is broken up into OB subtract OA, then by extension, if we had to find PQ, it will be broken up into OQ minus OP. Okay, students, so we are going to try a few questions on screen to show you the application of this vector rule, and you can see how simple it actually is. Okay, so I'm going to try to pull in a question on screen there, where I am going to, okay, so we have a nice little worksheet here, and I'm going to bring it up on screen. All right, so we have three lovely questions showing on screen there, and they look a bit complex, but let's learn a couple of things. So first question, they have given us coordinates, and they're asking us to find 8PQ. Now, before we find 8PQ, let's begin to find PQ. Now, I will place a recall that the vector PQ, from what we just previously learned, will break up into OQ subtract OP. And also, there we go. And seem to write very close to, okay. And also in this question, you have been given coordinates. So we can safely transpose those coordinates to vectors. So the coordinate P will be transposed easily into the vector OP by writing it as a column, or writing it vertically like that. Similarly, the coordinate Q can be written as a vector by writing it vertically like that. And now what we are going to do is we are going to use our rule, our vector rule, and we are simply going to learn how we can add or subtract vectors. So substituting, we will get PQ is simply equal to, let's see, OQ is -1, 9, subtract OP is 0, -4. And when you are doing or calculating vectors like this, you want to work across. So you'd say -1, subtract 0, that gives you -1 on the top. And then working across on the bottom gives us 9, subtract -4. That's 9 plus 4, that's 13. Therefore, the answer for this question for PQ is -1, 13. Now they want us to find the value of 8 PQ. How are we going to do that? Well, you can actually multiply vectors by constants by simply multiplying each of those values inside your brackets. So we multiply 8 by -1 to get -8 on top, and as well we will multiply 8 by 13 to give us 104. Okay, so I'll erase some of those things that my pen has written, and we are having some technical difficulties here. All right, so that's 104. So guys, that's how you would work a question like that. Now we'll be moving on to the second example. So for the second example, they have that they want us to find PQ plus RS. Now I'm going to leave this up on screen here because we already have PQ. But in this question, we have different values for OQ, and we have different values for OP. So in this question, OP is going to be equal to OQ subtract OP. Now, what is Q written as a column vector? Well, that'll be 6, 10. We have simply written our horizontal coordinate vertically. So you're moving from coordinate into a column vector. Similarly, we'll do the same for P. We'll have -7 here and -6. Carrying out a series of simple calculations horizontally will give us 6 subtract -7. That's 6 plus 7 is 13. And 10 subtract -6. That's 10 plus 6 gives us a value of 16. All right, and that's the value for PQ. Seems to be getting way easy, isn't it? Now we're going to work out RS. So before we work out RS, we need to take our time and use a vector rule that splits this up, because we do not have values from R to S directly. So we have to use our vector rule, and that splits up into S subtract R. Now we are going to substitute our values that we have. And our values are O to S, let's see, that's -3, 7, and O to R is -3, -9. Nice. So we are going to do our simple calculations here, and we have -3 subtract -3. That gives us 0. And then we have 7 subtract -9. That gives us 16. So now we have our values for PQ and RS. PQ worked out to be 13, 16. And RS worked out to be 0, 16. I hope I am working out my values correct. I'm just working them off the top of my head. So if there's any small calculator errors, please forgive me, but you get the point. Okay, guys, so that's how to work out question 2. Now we are going to finally see how we can attempt question 3. Okay, so it isn't that bad. I'm going to do a lineup of all my column vectors that I have. So the first coordinate I have is t. So transferring my coordinate into a vector, we will get -3, 8. We have OX, and that's 3, 10. See guys, very straightforward. Just write it from horizontal into vertically and pops a O in front. We have OY will become -4, -7, and similarly O to Z becomes -8, -10. Okay, so I have written all my coordinates as column vectors. They are all position vectors because they start from O. And now we're down to business. So let's see what the question wants. Well, first up, they want us to work out TZ. So TX will break up into OX subtract OT. And we have all of these values. They are OX is 310 subtract OT. That was OX. This is OT here. -3, 8. Doing calculations, we will get 3 subtract -3, that's 6. And 10 subtract 8, that's 2. And if I can possibly fit this on screen, let's go one shot up and let's work out YZ. So YZ simply broken up into OC subtract OY. So I hope you guys are picking up a pattern here. When you are splitting a vector that has 2 definitive points, one of which is not O, you just split it up into 2 position vectors, and it's always the second minus the first, so Z minus Y, and you just simply write O's in front. It's not that difficult to separate. All right, and now we are going to simply substitute our values. We have OZ being -8, -10, and we have OY being -4, -7. Going ahead, that's -8 plus 4, that's -4. And then we have -10 plus 7, that's -3. Now, we are not finished. They want us to work out 4TX plus YZ. So 4TX will be 4 multiplied by, recall, TX was 62, plus YZ worked out to be -4, -3. Now, before addition, we must always make sure that our vectors are all written, everything is written inside of that bracket. So we want to make sure we bring that constant 4 inside. So we're going to actually get 6 4s are 24, and 4 times 2 gives us 8 before we perform addition here. And finally, performing addition, our answer works out to be 24 plus -4 gives us 20 on top, and 8 plus -3 gives us 5. And that's our answer to this question. So if you guys would like more tutorial questions showing how to use and apply the vector rule, I will be happy to do them. You can send me your questions. Just leave a link, a description, a comment down below, and I'll be happy to humbly oblige. So all the best, guys. I hope that you understand vectors now. I hope it's been easier for you guys, and I wish you guys all the best. See you next session. Bye.